Hi and welcome to this episode of Shop Miscellany. So I'll start with an acquisition I made. It's not this. So this indicator stand is a Starrett and the design is pretty old, but this one I've had for a long time. Bought it off eBay, got a pretty decent deal. Recently my brother-in-law is moving his parents out of their home and cleaning up their garage, and they found a stand very similar to this. Not exactly like it, a little bit different design, closer to the Asian knockoffs. The difference was it was completely rusty. So rusty that none of the moving parts turned, which, you know, if you watch my channel for a while, you know that I can't stand rust. This one's in pretty decent shape, but not perfect. In any case, I took the other one, soaked it in some Evaporust like this for about a day and a half. And when I came back, it was in much better shape. Took some Scotch-Brite to it and cleaned it up. Took the base, which, unlike this one, which is all curved, Starrett loves their curves, but these pins are harder to move around than the new design. Anyways, Starrett loves a lot of curves. This one's square on both sides, so parallel sides, and front and back were also somewhat parallel. So I took it over to the surface grinder, cleaned it up, and I was very pleased with how it turned out. You're looking at just oil marks on here, so I ground the top, I ground the bottom. This had some part where the rust etched in rather deeply, and I didn't want to go all the way through, but cleaned up pretty nicely. It's a pretty beautiful surface. You can tell this is nicely hardened because the surface grinder left a fantastic finish on it. Put this guy in the lathe and some Scotch-Brite and cleaned it up pretty nicely. And the Evaporust took all the rust out of the cinch down here and did a pretty nice job with it. So this thing works pretty well now. So that was a really cool find. Just took a little bit of effort. I didn't show the surface grinding because it was really straightforward. I surface ground this piece here as well because it was totally rusted to the point where it wouldn't move. It was actually hard to get out of here because the rust was so bad. But I ground it down, and now it looks and works really great. The pins I was mentioning, this is a Starrett, and see they have roll pins there? That's nowhere near as good as this design, where you can just push these guys out to slide up against an edge. And they're a different design. They actually have in the middle a little spring that presses out so that there's just friction. By the way, these were all frozen too. I had to hammer these guys out. Now they're finger tight and you can slide them. So pretty good find, I think. Next up, I was using a project where I needed these transfer punches. You saw that project. That was the conveyor. Hopefully you saw it. That was one video ago. That was the conveyor lift system for the laser seam welder. And I was using these transfer punches from Harbor Freight, which was a really good deal when I bought them. But going into sheet steel, just a couple hammer punches later, and that's what you end up with. So they sucked. I don't think these are very hard. I was going to take this over to my Rockwell hardness tester and see how hard this is, because these were horrible. They're almost unusable. Punching them into sheet steel and they round off that much, that deformed. That didn't like break off or anything. Pop this guy into my hardness tester. Let's just see how hard it is. So let's get to 0 here. There we go. Preload that. And there we go. Needle's moving pretty quickly, which means it's penetrating into the material pretty quickly, which means that the hardness probably is not going to be very high. Rockwell C25, so no, it is not very hard at all. Since those transfer punches folded over on the very first use, I picked up another set. These are Nico. I don't know if these are a lot better. They cost more, but that doesn't mean anything, right? They did say that the key features are their heat-treated alloy steel. So those other ones were probably heat-treated too, because they're Rockwell 25. But hopefully these are built much better. I'm going to take one of these over to the hardness tester and see how hard it is. So we've got the Nico or Nico, I don't know how you pronounce it, punch. A lot sharper than the Harbor Freight one, just for starters. It's loaded in the Rockwell hardness tester. It's loaded up. Preload, and watch it go. See the needle's moving slower on this one, which usually indicates that it's harder because that means it's not penetrating into the material very quickly. The answer is Rockwell 55. So it's definitely going to be better than the Harbor Freight Rockwell C25 hardness ones. And you can see the tip is a lot sharper than the Harbor Freight. Here's a never used one from Harbor Freight and the Nico. It's amazing how similar they look, but the materials are quite different, I'm guessing, just based on the hardness difference. This set should last a lot longer. So in with this set, oh, there you go, there's a name on it. Out with this set. The base looks like it's same exact manufacturer, just different color plastic, even the text. And this has a 1730 seconds, and the small ones identically. So probably made by the same manufacturer, just to a higher spec. So this set will just go in my scrap metal bin to use these as pins or something. And this set hopefully will work better for me going forward. Next up, I got this quick project to turn this bar stock, this 321 stainless steel, into some hollow tubes. 15 thousandths dimension on the inside diameter. This is 321 stainless, which has a machinability of about 50%, which means it's not very, and it's going to kind of suck. So I bought a carbide drill bit for it. This is I'm using an S, and an S drill bit should do 0.348. And I went on the low side because sometimes drill bits drill oversized holes. So we're going to try that. And once both sides broken, plus or minus 10 thousandths on the length. So we'll see if we can set that up in the lathe and knock this out. Sorry about all the racket, but I have to have fans on because it's 102 here in the garage. So got a collet closer here. In the past, I used this Atlas 5C collet holder. For the lathe, there's a D16 holder. And as you tighten this outer ring, it pulls the 5C collet in. The problem is that when you take the bar to loosen it and then retighten it, if you don't put this ring in exactly the same spot, it doesn't pull the bar into the same position every time. So your depth is not terribly repeatable. So we're using the collet closer instead. That collet closer is sort of bistable. There's loose and tight. And when it's tight, it pulls back to the same position every time, fairly repeatably. In the head here, you have a 6 MT holder with a 5C collet that fits inside. And there's my stock right there. Mounted on my tool post here is this bar assembly that I made in a much earlier video. Sort of took the idea from Joe Piesinski. I haven't set it properly yet. One side is thin, the other side's square. And what it allows you to do is to back your stock up here, go in, pull the stock out until it just touches here. Right now it's not tight, but pull the stock out until it touches. That's your 0 point. That lets you repeatably do all of your cuts every time accurately. And that's what we're shooting for, since I have to make a bunch of these parts. First step before I can set anything up is just to face this end here. And I hear that 321 stainless steel is difficult to machine. Gets a machinability rating of 50. Okay. So now I got to set this up so I can drill out the center and then part it off repeatably over and over. All right, so you have this guy in front of the bar stock. You loosen it, pull the bar stock out, tighten it down. Once you tighten it down, it'll retract ever so slightly from the face of this guy here. This guy is locked off at the point where it'll cut off a .780 piece of material. So I'm going to center drill the first one, but then I'm going to use this carbide drill bit to drill all of the holes. So every time I got to make the hole deeper, we'll have to come back in here and retract this out of the way, drill. This hole depth is all the way through, so I don't have a specific depth I need to go to. And I figured once I've got the starter hole, that may be too high an RPM for this. So we kind of have the process down now. I've got my cross side locked off longitudinally. So we unlock the 5C collet, bring it forward and push it into the pin. Lock this off. Deburr the inside briefly. Deburr the outside. Now we got a drill, because I'm only in like, I don't know, 4/10 of an inch kind of thing. And I think one of the tricks is not to let this stuff heat up too much, because I think the hotter it gets, the gooier it gets. I might be wrong. Okay, that's 3/10. And you can see that actually not so bad, or is it? The chips tend to stick when they get hot. And I fill the hole with coolant. You can see the drill bit's getting kind of hot. What I really think you need is a coolant through drill bit to do this. Okay, let's get that out of the way. Just bring this guy straight on in. It retracts like a couple thousandths, just enough to clear that automatically when it tightens. More importantly is the repeatability's been around 2 to 3 thousandths, which isn't bad. And maybe with better technique, I could do better. And then we'll get ready for the next one. Deburr the inside. Deburr the outside. Put this back, pull it out again, drill and repeat. To remove the material that's left over on the part, even though there's a slight bevel on that, I take a pair of diagonal cutters that are designed for hardened steel, these Lindstroms. These are pretty fantastic. And it still leaves a bit of a burr that I have to use my deburring tool, the chamfer tool, to remove, but it gets most of it off pretty flush. All right, so there we are, project completed. I got 13 pieces out of that bar. A little bit of rag on there. Lost a 1/4 inch end mill, exploded, toast. S carbide drill bit got wasted. I resharpened it. Looks like it'll be reusable, but that was pretty ugly. This 321 stainless, if I never meet it again, be too soon. I think I found that you got to push hard with the feed, and you got to pull back and go in and out quickly so that it engages and then disengages. Otherwise, it'll turn up a burr. Also, I think if it gets too hot, it gets a little softer, and that also makes you risk turning up a burr. Anyways, again, 321 stainless. I'll take hints from anyone who knows better than I. I have no experience with it, never done it before, but as it stands, I'm not very happy with it. All right, thanks for watching. Hope you find it useful. Hope to see you next time.